Okay, I started the recording back. Now it's 11:46. So let's finish up. Now we move on to elements of a measuring or measurement system. So when we want to measure something, we can generally classify the parts of the measurement system into three. So the first part is the sensing part. The second part is the signal conditioning part. And the third part is the readout part. Now, without looking at the definition, let's see whether you can make sense of this figure. So the first part is the sensing part. So when we want to measure something, we must have some form of sensing element. So the sensing element can be either manual, or it can be either electronic, or it can be a combination. Okay. So if you want to measure the length, we use a ruler. So the primary sensing element is the ruler and our eyes. But for more complicated measurement, then we need to use maybe some sensors. Right? Okay, so the first part is to detect the value. The second part, signal conditioning, is used to improve the reading, to make it easier for us to read the value. So under signal conditioning, we have variable conversion and variable manipulation. We'll see what this means in the next slide. And the third component is the readout. After the signal or the medium has been measured, it must display a value that we can understand. So depending on the complexity of the measurement system, sometimes we only directly have from the measurement, directly we can see the data or the output or the display. But now, many of the equipment or the instrument used to measure, they have number one, data transmission. And then we have data storage, where we can store the data for later use. If you want to analyze the data, the historical data later, so we need to have some storage. And we need to be able to access them or play back the value. Some advanced meters already have this embedded in their software. So we can directly see from the meter what are the historical values. Sometimes it's we need to download it and see in our a computer or laptop. Okay, and then the display or the data presentation element to the observer. Now let's look at the definition in more detail. So the primary sensing element, we call it as a sensor. So it gives an output that is a function of the measured medium. We call it also as measurand. And it is approximately linear. What is meant by approximately linear? That means if the value goes up, then the sensor should also have higher reading. If the value goes down, then the sensor should have a lower reading. It should be around proportional. Okay, so that our reading makes sense. So example, digital thermometer and strain gauge. Okay, after you have the sensor that sense the element, now we need to convert the value from the sensor to a more convenient form. Okay, this example is close to you guys as future manufacturing engineers. So you have strain gauge. Strain gauge, you want to measure small displacement, okay, small movement of a certain object. So the output is in the form of varying resistance. Although you are measure distance, but the output is in resistance value, electrical resistance. But resistance change cannot be easily measured. Okay, it's quite difficult to measure resistance change. So it is converted into the form of voltage. Convert from resistance to voltage using what we call as a bridge circuit, so that the change can be detected more accurately. Okay, so we convert from resistance to voltage, equivalent value. So a change in voltage will correspond to a change in actual distance. Okay, when we come into this topic later, I'll show you how the conversion is done. Sometimes the sensor or the primary sensing element are combined together with the variable conversion element together as one set. And under this condition, they are typically called as transducers. You'll see a lot of this in your career later. So the next part is a variable manipulation element. So variable manipulation is basically when we have the signal, we want to improve the output of a measurement system. So common example, number one is amplifier. So if the signal is too small, then maybe we cannot read it properly. So we use an electronic amplifier to amplify the signal or the original reading to make it easier to detect and easier to read. Another example of signal processing or variable manipulation element is by using a filter to remove noise from your measurement. Okay, when you do measurement, sometimes noise also is included in the reading. So you want to filter that out. So you use some filters to do that. So these are called variable manipulation element. The fourth item is data transmission. Data transmission is when the location of the measurement and the location of the display is far away from each other. So you need to be able to transmit the data. So common, either we use using wired or wireless. Okay, so wired systems, they typically use fiber optic cables. Even though normal cables also possible, but fiber optic cables is beneficial because of low transmission loss and immune to electric and magnetic field. Okay, so the signal is not distorted. So wireless system, they detect using light signals, similar to our mobile phones. The fifth element is data storage. Okay, this one is pretty straightforward. We want to have historical reading of our historical record of our reading, and we want to use it for comparison or evaluation later on. And finally, we have the data presentation element to display the data and make it easily readable. So these are the elements of a measurement system. Now we are moving towards the end. These are the categories of standards. So the categories of standards, if you Google yourself, actually there are a few terms that are used differently. But in this topic, we are going to confine the terms to these four. So we have international standards. At the top of the pyramid, we have the international standards, SI. And then below it, we have the primary standards. And after that, we have the secondary standards. And finally, we have the working standard. So on the right-hand side here, you have the accuracy arrow, which indicates that as we move upwards towards the top of the pyramid, the accuracy becomes much higher. Okay, this is logical because international standards, of course, is more accurate than the standards used at the application level. Okay, so the width of the pyramid here, or the width of the triangle here, is the level of uncertainty when you do measurement. So for working standards, the uncertainty is quite high. That means the compared to international standards or primary standards, so the uncertainty is much smaller. So uncertainty and accuracy is directly correlated. If accuracy is high, that means uncertainty is going to be low, and so on. Okay, and then there's this arrow here, which indicates the traceability. So I'm going to describe about traceability afterwards in the next few slides. So let's look at the definition. So international standards are defined by international agreement from all the nations representative. It's the highest measurement accuracy with lowest uncertainty, and is periodically evaluated and checked. And there is a special bureau located in France that maintains the standards and do the proper evaluation from time to time. Then we have primary standards. So primary standards are also known as national standards. These are the closest standards that we can access. So it's maintained by each country, usually by its national laboratory. In Malaysia, it is under SIRIM. So actually SIRIM, not SIRIM itself, under SIRIM they have the National Meteorology Institute of Malaysia, which is the body that is in charge with maintaining the national standards. Okay, but make it simpler, we say SIRIM. So all the measurements done inside our country is based on SI units, is validated under SIRIM. So CIRIM calibrates all the equipment used for measurement independently by absolute measurement, and it's not available for use outside the national labs. Okay. Next, we have secondary standards. So these are the basic reference standards used by measurement and calibration lab in the industry to which they belong. So for example, in the manufacturing industry, okay, they have some reference standards, they have some reference equipment, so they are going to refer to secondary standards. So secondary standards also refer to accredited third-party calibration lab. So example, we have SST, which is a CIRIM subsidiary, and these labs here are calibration lab where they control the secondary standards. And they periodically send to the national lab for calibration with primary standards. And finally, we have the working standards. So working standards are the principal tool for lab measurement used to check and calibrate the instrument or make comparison measurement. So these are available in every factory or processing plant or companies involved in measurement. Okay, for example, Proton. So Proton car manufacturer have their own in-house laboratories that calibrate their measurement instrument to ensure accuracy and reliability. Okay, so let's see the sequence now. At the bottom part of the triangle, we have the working standard. So let's say now you are an engineer in Proton. So first, you have your own measuring instrument you use for everyday work, to measure. And then you must ensure that your measurement is accurate and reliable. So from time to time, your equipment needs to be sent to the secondary standard, third-party calibration lab, so that your equipment can be calibrated and make sure it performs correctly. Now, at the lab themselves, they have their own calibration equipment. The lab need to send their calibration equipment from time to time to the CIRIM National Standards Lab. And then the CIRIM must ensure that their measurement and their calibration equipment comply with the international standards. Okay, so now if I go back to the triangle, you see the sequence. Working standards at the bottom, you need from time to time calibrate your equipment with reference to the secondary standard. The secondary standard, from time to time, need to calibrate with primary standard. And primary standard, from time to time, need to make sure that their equipment follows the international standard. So this sequence from bottom to top is what we call as traceability, the ability to trace a certain measurement from the lower level up to the highest level. Are the terms and definition. So you can read this on your own. What is a measurement standard and what is a measurement traceability? So basically the measurement standard is we want to find a measurement that uses a standard reference that can be agreed by all parties. And traceability, we are talking about the measurement itself, the quality of the measurement can be traced up to the national standard through an unbroken chain of comparison. And this is the summary of our lecture today. So the course is all about measurement process and methods. Measurement must consist of a number and a unit. The measurements are based on SI units. The measurement element consists of sensing element, signal conditioning element, and display element. And finally, for a measurement to be reliable, it must have traceability to national standards. Okay, so now before I end, let's go back to our learning outcome to make sure that I have covered what is intended to be covered today. So let's see, by the end of the lesson, the student will be able to explain the basic concept. I've already done that. Describe and use SI units. I have described, but of course the use of SI unit we need to explore a bit later. But we know how to use it. That's the important point. identify and describe the elements of a measurement system. I already explained to you about that also. And describe the categories of standards and its features. So I've covered the objective that I want to cover today. So our class is finished, but before you sign off, please do the following. Log in ULearn. So mark your attendance manually and answer the short quiz in ULearn. So if I open ULearn now, I check the attendance first. Okay, so some of you have already self-recorded. So there are still a few who haven't recorded their names yet. Okay, like Adam, Pansuri, Ahmad Adlan, Arif Naim, Chong Jun Hong. Okay, so please you do so before 1 p.m. Still have a lot of time. I'm not sure because some of the names listed here is not in my attendance list. You are from other groups, so we'll wait until next week to sort the grouping if required. Okay, so let's see. Many of you have self-recorded, so that's good. Let's see the next page. If your name is not, you haven't recorded yet, please do so. Okay, Nabil, Ashraf, you are the earliest one who came into my class. So please make sure you record your attendance. Okay, and these are the last list. All right, so then the quiz. I've already make it available. You should be able to see here. So there is an option for you to answer mini quiz week 1. There are 5 questions, multiple choice. There will be no assessment. These are just for attendance purposes. I just want to see whether you understand, whether you are following the material, whether I'm clear about the things I explained. Right? So please do so before 1 p.m. And that's it for today. Thank you for your attention. I hope you are not discouraged. So Irfan tanya, got mark for the quiz? Ada dalam tu ada marks lah. You get how many marks, but it's not going to be recorded in the official assessment. Okay, once I declare, okay, nanti quiz ni akan masuk, I will let you know. Okay, because this one is week 1, we are still not sure about the grouping and everything, so I'm not going to consider this as part of the assessment. Okay, so far, yang 1 jam, this 1 hour that we are together, are there any problems or glaring issues that you need to highlight to me? Okay, Diana, apa dia? Okay, siapa yang tak ada masalah, you can log out lah. You can answer the quiz.
Boleh dengar ke suara saya?
Boleh.
Okay. Okay, sir, ada classmate saya seorang, dia ada masalah dengan Microsoft account dia, jadi dia tak boleh masuk session hari ni.
Baik.
Jadi macam mana tu?
Siapa nama dia?
Dah Linda Shazana.
Okay, dia dah apa tadi?
Dia dah, saya rasa dia dah contact sir, tapi saya boleh check lah. Saya just inform kat sini je dulu.
Mungkin sebab saya tak buka phone kan?
Okay.
Okay, jadi tak apa, dia record attendance dia dulu. Dan nanti material video ni saya akan cuba edit dan upload juga dekat YouTube supaya boleh access in the future.
Alright, thank you sir.
Thank you Diana.
You're welcome.
Right. Okay.